Hi class, we are now in chapter 12.3. This is a very short section. We're going to be looking at surface tension and viscosity. So what exactly is surface tension and viscosity? Well, when we're dealing with intermolecular forces, specifically with concerning liquids, there are other behaviors that we can determine are based on intermolecular forces, and they are surface tension and viscosity. We can see these things, and they are part of intermolecular forces. So we can see how strong these intermolecular forces are to each other based on surface tension and viscosity. So if you put a paper clip on water, it will float very carefully, and that's being held up by surface tension. It will not float on gasoline because gasoline has weaker intermolecular forces, and it will just sink because it is more denser than gasoline, and it's also more denser than water, depending on what type of paper clip it is. So because of this, it should normally just sink, but it won't sink because of the fact that the surface tension, it has to overcome this attraction of these molecules in order to pass through. Now, eventually, if you poke at it, it will go through. That is the surface tension. That is what keeps it holding on. I found this slide with these droplets, and I figured this is a good example. It's defined as the tension, the tension that's on the surface is because of the attraction of the particles, and that attraction is the intermolecular forces. So they minimize, so surface tension is the tendency of liquids to minimize their surface area. They pull together, and that makes them kind of stronger because of it. They kind of lock hands, if you think, and pull each other close, and that makes it very strong. So that's why the paper clip just won't sink through, even though it is denser than water. So based on density, it should just go straight through, but the surface tension is not allowing that to happen. So eventually it will, like I said, if you kind of push it and so forth. So why is surface tension the way it is? So if we look here, we can see water molecules, and water molecules have other water molecules around it. So there's this attraction between all of these water molecules that are in the center. They're all pulling and pulling towards each other, so it makes a strong bond. However, at the surface, they don't have above the level of the surface of the water. There's no other molecules above that to pull. So what it does is it tends to give this downward pull action on these molecules, and by doing that, it pulls them together this way and it pulls them downward. Or see, these are all towards each other. This tends to give them, because these here are pulling it, it tends to pull them down. So it gives that downward force, and that downward force of attraction allows that surface tension to happen. So that's why this downward pull causes the liquids to minimize their surface area. So it allows them to have that kind of skin, is what your book kind of calls it, a surface skin, to allow it to have something that can sit on it. So viscosity is the resistance of a liquid to flow, and you can see it very clearly in this picture. You see one will pour very easily, and another will kind of be very, very slow. And that is, again, the intermolecular forces that hold that together. And depending on how strong they are, it can be poured easily, or it could pour very slowly. So the more viscous something is, so high viscosity, you have to put more effort into stirring it. Low viscosity, you can stir it very easily. It will go, or it'll pour out very easily. And that is because, so higher viscosity has to deal with stronger intermolecular forces. They can't really move around as freely, and so that hinders that flow to them. And so long molecules also is such as hydrocarbons, and hydrocarbons are hydrogens and carbons put together, attached to each other, such as motor oil. They tend to form some viscous liquids because they have very long chains of these carbon and hydrogen bonds. So that's what it's saying by molecular entanglement. Think of like tails. These tails get caught in with each other. So viscosity is the resistance of liquid to flow, and the higher the viscosity, the slower that will flow. And the lower the viscosity, the easier it will flow. And surface tension has to do with those attractions. They pull together and make that kind of surface skin that doesn't allow things to sink. Maple syrup is more viscous than water. You can see that if you pour that, and that's because those molecules interact strongly. So there's a stronger intermolecular forces that don't allow it to flow as easily.